Hi, I'm Jelle van der Waa. I work at Red Hat, and I also am an Arch Linux developer. And yeah, so normally once a day in a week, I go to this co-working space, and like others probably, you have a work laptop. So I bring it there. It's like 80% charged. Plug it in. It will top off. Maybe head off for a meeting. It will drain a bit again, and plug it back in, it will be charged to 100%. And this isn't great for your laptop battery, so turns out there's a kernel API to remedy this. And with that, you can basically control when your laptop battery is charged. So this API has a start and an end threshold, and you can, for example, configure it, say, 60-80, it will end charging. If your battery is like at 0%, it will charge all the way to 80%, and it will only start charging again till it's below 60%. And with that, if your laptop is always plugged in, it's not constantly getting this trickle charge, which charges the last X% of your laptop's battery. And that should make sure that your battery lasts longer. So that is great. And since GNOME 48, this is like a setting in GNOME, and this is supported. But it only works with laptops which have these two files. And it turns out there's like more laptops than Linux which have such similar mechanisms, which we didn't support yet. So this is what the talk is in general about. Because in the end, in UPower, we want all laptops which have a battery care or preserving feature to be supported. So I dug this out, also with the help of the guy who wrote the GNOME. There's also a GNOME extension, and it turns out that there's like multiple cases which I didn't handle. So the current UPower release only handles the start and end limits, so where you can configure both. But there are also laptops out there which only have an end limit, which is configurable from 60 to 100%. And then there's some laptops which only have one fixed limit of 80 and 100. And then there's the Dell laptops, which are a bit funky. They have the start and end limit. But they, for this to activate, you need to set the charge type property to custom. And that's also not handled by UPower yet. And then there's all these devices which are probably all the support was added before the charge control start and end properties existed. So they have their own custom API, which isn't great if you're if you're a user space program and you want to like have an easy way to toggle on and off this feature, because you would need to check like, okay, is this a Samsung laptop? Then I need to do this, and if it's a Sony laptop, then this. If it's a Asus, I can only set it to 16 to 100. So that's all about a bit annoying. So I discussed this with my colleague Hans de Goede, and he was already looking into this charge tape API, because as I mentioned on the previous slide, for the Dell, for UPower to set these limits, it would have to set it to custom. But turns out, as you can see in the example below, the charge tape API just gives you the current value. So it's not really user space. As a user space program, you basically would have to try to write like, oh, does this support custom? I'll just try to write to it, and if it doesn't, it will error out. So that's not really a great experience. So he wrote the charge types API, which is basically the same as the charge type API, except as you can see in the output, it shows what the current selected value is and what other values are supported. And by the way, the charge type API supports more things. It can set like fast charging and stuff and other stuff. And another interesting feature of the charge type API is that it has this long life property. And this is actually would be a nice property to reuse, also for, say, an eco or battery preservation mode. So we discussed this and came to the conclusion that we should just port all the existing drivers over to this API, which have just this single switch, like, for example, the ID pad. So yeah, turns out these laptops can be acquired for like 40 bucks. So I bought one, I ported the driver over. This was made fairly easy because now there's a battery extension API now made by Thomas Weisschutz. And yeah, done, tested, and this now is merged in, I think, in 6.17. And while I was working on this, a colleague of mine, Kate Hassan, already started the UPower work. So in UPower Master, it already supports the Dell use case and the ID pad. So basically everything we've had has a charge type long life. It will now detect this, and it will, it will now show, basically in GNOME settings, there's no code changes needed, only UPower needs to be updated, and now you can set the battery preservation option on. So that's great. There are more laptops which I wrote a driver for, so I, like the Samsung one was also merged, so I reached out to the community and I found someone who could test this. The LG laptop I also have a tester for, but there's some delays, which is fine, and yeah. So another great fun thing I figured out while working on this is that you cannot really ask testers to like compile a kernel, and not everybody is as knowledgeable or wants to put in the time. So I talked with another colleague, and he maintains the image builder stack at Red Hat. And he showed that you can easily create your own Fedora install image with your custom kernel. So this is what I did. And then just handed somebody the ISO. He could burn it on an USB stick, plug in his laptop, and boot it, see if the charge types option was there, test it, and then report back. And then I could submit a patch upstream. So that was a convenient way. You can probably do the same with MakeOSI or Kiwi. But yeah, this was like a great improvement into getting my patches tested, because I don't really want to hoard more laptops. I already have like 5, so there's only so much shelf space I have. So yeah, there's still some leftovers for UPower support. So the case we don't handle yet is the case where you only have the charge end threshold, which is a limit of, like, say, it only supports a range of 60 to 100%. The kernel also doesn't advertise which values are supported, but according to the kernel documentation, it should accept the value from 0 to 100. Unfortunately, not all drivers adhere to this, and the Fujitsu driver used to give you invalid if you wrote 50, and now I submitted a patch, and this, I believe, is also lands in 6.17. It now just clamps to 60%. So if you write 50, it clamps to 60. So in the future, we can also easily support this, because we can just write a limit, and we won't have to deal with any errors. And also to get some, there is also like 4 or 5 out of 3 drivers to support battery conservation, but also other features. So I reached out to the Acer WMI battery extension driver and ported it over to the battery extension API, and I'm waiting on people to test this, and then I can also submit this upstream, and then even more laptops are supported. Yeah, since I still have some time, another cool feature to support is battery calibration. This basically allows you to recalibrate the internal battery, because if you apply these limits for too long, you haven't had a full discharge and charge cycle, so the internal counters won't be updated, and the estimation probably won't be as accurate. And ThinkPads and the Framework laptop support charge behavior for this, and that's something I also want to do in the future. So, and then I ran out of time. So.